Hi, and welcome to our next video on Semantics Pragmatics. This week we're going to talk about meaning and truth. As you remember, we've talked about the relation between meaning and reality several times in the course of the last weeks. Today we're going to make the picture more complicated by adding the factor of truth. So whenever we use our language to say something about the world we live in, we can also say whether that statement was false or true. We are using the category of truth in this case. Sometimes we can even imagine that certain expressions are false, but they might be true in another universe of discourse. Or if the state of affairs that we are currently living in would be slightly, or more or less slightly, different. How this works, we'll see in a second. So let's have a look at what is sentence meaning against the backdrop of truth. So based on the relation between the extra-linguistic world, expressions that we use to talk about it, and the category of truth, we can say that sentence meaning, a definition of sentence meaning can look like something like this. To know the meaning of a, in brackets, declarative sentence is to know what the world would have to be like for the sentence to be true. This is what I meant a second ago when I mentioned the different states of affairs or the different universes of discourse. In other words, the meaning of a sentence is determined by its truth conditions. And truth conditions means what needs to be true if the sentence should be regarded as true. Right, so let's have a look at an example, a very simple one. So the sentence is, King Henry VIII snores. So this sentence contains a proposition, P. This proposition is, in this case, very simple. King Henry VIII snores. In our current world, that proposition is plain false because Henry VIII is dead and therefore he cannot snore. There is also no King Henry VIII at this moment, so for that reason also he cannot snore. What would have to be true is that the world in which we utter this proposition would be the world of the beginning of the 16th century in England. There we might plausibly say King Henry VIII snores, even though we would not be able to say whether that is correct or false unless we know King Henry VIII personally. Right. So let's have a look at truth conditions. So based on truth conditions, we can distinguish between at least three different types of sentences or propositions. So first, we have the so-called analytic sentences, also known as tautologies. So those are sentences that are, regardless of the situation, always true. The truth conditional content is basically absent, but we might use them, and we actually very often do, for pragmatic reasons. And pragmatics is something that we're going to talk in more detail in the coming weeks. But imagine sentences such as, today is the first day of the rest of your life. This is always true regardless of the time when you say it. It's always the first day of the rest of your life. Or que sera, sera, what will be, will be. Okay, this is always the case. Then there are contradictions. Contradictions are, in contrast to tautologies, propositions that are false in every possible context. For example, if we say something like, your children are not your children, this is obviously false because your children are your children. And again, these expressions, these sentences, are used in order to express something pragmatically. It's not the semantic content of these sentences is not that relevant. And in between these two extreme poles, we have the so-called synthetic sentences. Those are sentences that are neither tautologies nor contradictions. They are in some situations false, in other situations they are true, such as the sentence that we discussed in the beginning with King Henry VIII snores. Right. You might remember from your introductory classes to linguistics that there are, when we talk about truth and meaning, there are these two big concepts, and one of them is entailment, the other one is presupposition. We're going to discuss them briefly on these slides. Right, so let's have a look at entailment. So, if we compare the following sentences, Edward VIII has abdicated the throne in order to marry Wallis Simpson. And sentence B, Edward VIII is no longer the king. So we can then say that sentence A entails sentence B. And that means that if the first sentence is true, the second must be true as well. The second sentence, the truthness of the second sentence logically follows from the truthness of the first sentence. And vice versa, if the second sentence is false, the first one must be false as well. We can see that this works if we have a look at sentences such as the one that I marked with 3 question marks. Edward VIII abdicated, but Edward VIII is still the king. Right? So this would normally not be possible because here the second sentence is not entailed in the first one, even though it should be. Or if we say something like Edward VIII abdicated, but I'm not sure whether Edward VIII is still the king. Right? This should also not be possible because from the first sentence, Edward VIII abdicated, it follows because the second should follow because it is entailed in the first one. Now, let's have a look at presuppositions. Similarly to entailment, presupposition is a type of inference, of something that we assume based on something else. In the case of entailment, it was assumption of one proposition based on another proposition. Here we have a assumption based on the so-called common ground. And what it is, we'll see in a minute. Right, so presuppositions are based on common ground and on information that is linguistically encoded in a certain expression that is based or that assumes some common ground between the speaker and the hearer. This is something that we talked about when we talked about intersubjective reality of language in week 4. Right, so let's have a look at this sentence from Alice in Wonderland. And here, the March Hare says the following. "Take some more tea," the March Hare said to Alice very earnestly. "I've had nothing yet," Alice replied in an offended tone, "so I can't take more." Now we see here the word more functions as a so-called trigger for a presupposition. In this case, when the March Hare says, "Take some more tea," it presupposes that Alice already had some tea. And she's then offended because she hasn't had any tea yet, and the March Hare hasn't offered her any. But this is this word that triggers this presupposition, right? So the March Hare assumes that Alice already had some tea, which is not the case. And that is why we, in this case, see a presupposition that failed. And that is because this presupposition that the March Hare had was in fact not part of the common ground between Alice and the March Hare. This is not always a bad thing, and very often we do this when we want to introduce a new information into the context, right? So if I say something like, if you don't know that I have a cat, and I say something like, "Oh, my cat got stuck in the tree yesterday," then by saying "my cat," I assume that you know that I have a cat, even though you don't know that, but I don't have to introduce this fact explicitly. I rely on the fact that you will not start wondering what cat, but that you will simply assume, okay, so he has a cat. So there are, and in case of Alice, we see a failed presupposition being replied to, right? So Alice says, "I've had nothing yet, so I can't take more." She comments on the fact that the presupposition fails, but this is not always the case, and very often people simply understand that this is something they should have known. Right. So let's have a look at how we can identify presuppositions and entailment. So let's have a look at this sentence. Susan has stopped dating that Albanian monk. In this case, we have the presupposition that Susan was dating an Albanian monk, right? Or that Susan is or was dating an Albanian monk. And this will also be the case. This presupposition will be there, even though if we have a negated sentence, such as B, Susan has not stopped dating that Albanian monk, this presupposition will also be there if we have a sentence such as, if Susan has stopped dating that Albanian monk, I might introduce her to my cousin. Or if we have a changed sentence such as D, Susan may have stopped dating that Albanian monk. This is something called a family of related sentences that is used to show the distinction between presuppositions and entailment. Because if we take this family of related sentences, we'll see that only the first one, only the declarative sentence, entails the fact that Susan is not dating that Albanian monk anymore. But sentences B, C, and D do not entail that, right? So the fact that Susan has not stopped dating means that the entailment of Susan is not dating is not there. We can also demonstrate that something is a presupposition if we use the so-called "hey, wait a minute" test developed by Van Fintel and Matthewson. So if I ask you something like, how's your drug cartel doing? And you react in a normal way and say, oh, well, it's going splendidly, then the presupposition that you have a drug cartel has succeeded. But if you say something like, hey, wait a minute, I don't have a drug cartel, then you show your interlocutor that the presupposition that you have a drug cartel has failed. And you can also use that to test whether something is a presupposition, and if something is a presupposition, and hey, wait a minute, and by adding hey, wait a minute, creates an unnatural situation sentence, then you know that that was a presupposition. Okay, so now let's have a look at the relation between truth and logic. So as you all know, and as we have also discussed on a number of occasions already, our language, not only English, but any human language, is full of ambiguity, vagueness, and figurative expressions, meaning change, and so forth. But nevertheless, there are people called formal semanticists who try to describe language in a meaning of language in a non-ambiguous way, in a precise way that will even allow it to make testable hypotheses about the meaning of our language. And this is something that people have been trying to do and have been doing and attempting and successfully at least since the antiquity. And this is also something that we know from the Middle Ages and so forth. So this is very old part of linguistics, language sciences. So to illustrate what I mean, let's have a look at this sentence. Either Joe is crazy or he is lying, and he is not lying. What does that mean? That means that Joe is crazy in this case. We have here two premises. The first one is either Joe is crazy or he is lying. Premise number two would be Joe is not crazy. By combining those two premises, we can conclude that Joe is lying. This is something that is called propositional logic. The actual meaning of the propositions is actually completely irrelevant in this case. What we are doing here is focusing on the logical words, on the grammatical structure of the sentence, and what does that tell us. In this particular case, we are focusing on the words either and or and not. Right? So in premise, we can rephrase the first premise as either A or B. Premise 2 can be paraphrased as not A, which leads us to the conclusion that B. Right. So when we talk about propositional logic, we use propositional operators and truth tables. Some of you might actually know this from your grammar school education. Some of you don't, but bear with me. So there is a set of basic propositional operators. First one is negation, with the meaning not, right? So we have here a negated version of the proposition P, not P. And the truth table is as follows. So if the proposition P is true, then its negated version is false, and vice versa. If it's false, then the negated version is true. Then we have conjunction. and again, here is the truth table. You don't. The details are not really that important now, but I'm just showing you this to show you how the operators work and what they actually look like. Then we have disjunction, or, right? That is slightly different from what we normally mean by or. What we normally mean by or, in English at least, is the so-called exclusive or that has the symbol XOR. And this is really the meaning of either or, because in the meaning of the disjunction operator, as you see in the table, also if both are true, then the disjunction, the disjunction works also if both of them, both of the prepositions are true. Right here, you see that the exclusive or is false if both are true. So if you ask somebody whether you want to eat a hamburger or a hot dog, and they say yes, right, then you know that they are not using the XOR operator. Okay, then there is this material implication, if then, right? So if something happens, then something else happens. And the last one of the basic operators is the so-called biconditional operator, also sometimes used in writing as if with double F, and if and only if, right? Okay, so again, to illustrate how this works, let's have a look at this situation. Mother tells her children the following: if it rains this afternoon, I will take you to a movie, right? So the question that we can ask here is, what are the circumstances that would allow us to consider what the mother says to be false, right? And now remember, we are now, when we talk about these circumstances, conditions, we're talking about what is the universe of discourse, state of affairs that has to be the case in order for this to be true or false in this matter, in this case, right? So we have here two prepositions. The first one, P, it rains this afternoon. Then we have the preposition Q, I will take you to a movie. And now we can have a look at, we can write a truth table depicting the possibilities that we have here. So if it rains this afternoon, this is true, then it follows that I will take you to a movie. This is also true, right? So both of the prepositions are true. Another possibility that we have is that it rains this afternoon, but I will not take you to a movie. So the first preposition is true, the second one is false. The third option is that it doesn't rain this afternoon, which means the first preposition is false, but I will take you to a movie nevertheless. So the second proposition is true. The fourth logical option that we have here is it doesn't rain this afternoon. First proposition is false, and I will not take you to a movie. The second one is also false. And now if you then take a look using the truth table for the implication here, you will see that if both prepositions are true, the whole sentence is also true. If the first one is true, so it rains this afternoon, but I will not take you to a movie, then the whole sentence is false. So this is the case when the mother would be lying. The remaining truth conditional options will lead to the mother not lying, right? And there is also the option of the biconditional if and only if reading, which wouldn't allow for this third reading, right? So if it doesn't rain and the mother will take the kids anyway, then if we have this biconditional implication, if and only if, this would also be false, which is slight difference to the normal implication. Okay, so we can use these truth tables to actually evaluate more complex logical formulae. And by more complex, I don't really mean more complex right now. We're at the very basic level. So imagine a sentence such as the following one. Either you graduate or you will not graduate. Here we have, again, a truth table with the values already filled in. And we here see the basic proposition. And next to it, in the second column, we see the negated version of that proposition. Then in the cells below, we see all the possible truth values, right? The proposition can be either true or false, and the same applies for the negated version of the proposition. And then what we have here is the formula that we want to prove, right? So we see it's the disjunction operator, meaning or, and we have, so the first proposition, either you graduate, you graduate, and the second proposition is the negated first proposition, or you don't graduate. And the value of this column can be calculated, or this is based basically on the truth conditional table of this operator, right? So, and we see that if the first one is true and the second one is false, this is the second line here, then the whole formula is also true. If we have the second line, the first proposition is false, the second one is true, this is the third line here, then also the whole formula is true. And this then leads, we see that in any case, the whole formula is true, which is described as a tautology, right? So regardless of the conditions, this sentence is always true. Analogically, we can have a look at a sentence such as, you will graduate and you will not graduate. You probably already know where I'm headed. Here we have a truth table for that expression. Again, the basic proposition, the negated proposition, and here the proposition, the first proposition, conjunction, so and the negated first proposition. Again, we can calculate the results by looking at the truth table of the operator, of the conjunction operator. And we see that if the first proposition and its negated version is false, then the whole thing is false, right? So TF, right? TF leads to F if we use the conjunction operator. The other way around, if the first one is false, the second one is true. This one, it also leads to a false result to the whole structure. This leads then to a contradiction. Remember, a couple of slides ago, I talked about sentences such as, your children are not your children. This is similar to sentences such as, you will not graduate and you will graduate. Right? So these logical relations between the individual propositions allow us to investigate the relation between the relations in their own right and not have to consider the meaning of the individual words. Now let's make the whole thing slightly more complicated, but only slightly, by looking at this sentence. This is also something that I've already introduced a couple of slides ago. Either Joe is crazy or he is lying and he is not crazy, right? So again, we can analyze it further and have the first proposition, Joe is crazy. Then we have the negated version, Joe is not crazy. And the second proposition, Q, Joe is lying. And now this is the whole truth table for this sentence. And we again here see the basic propositions and their truth values, right? So the first proposition can either be true or false, and the second one as well. Then we have here in the third column, we have the formula based on the column 1 and 2, and the truth values of the operator conjunction. Disjunction. Then the fourth column is simply the negated version of the first column. The fifth column is based on column 3 and 4 and the truth values of the disjunction operator. And the last one, the sixth column, is then represents the complete formula based on column 2 and 5 and the truth values of the implication operator, as can be seen here. Right, so this, again, if I rephrase the table in words, then we see first proposition, Joe is crazy. Second proposition, Joe is lying. This third column is Joe is crazy or Joe is lying. Fourth proposition, negated P, Joe is not crazy. This one means right, Joe is crazy or Joe is lying and Joe is not crazy. And then in the sixth column, we have the whole thing together. Either Joe is crazy or he is lying and he is not crazy, which leads to the conclusion that Joe is lying. So, and again, we see that in all cases, the result is a truth, meaning it's a tautology. And regardless of the possible universe of discourse, this structure will always lead to a result that is true. Right, so what does this actually tell us? So we can now say that anything that will have this structure, either something or something else and not something, will lead to the same result. By the way, we can also, based on this, explain why the proposition Joe is lying is entailed in the proposition either Joe is crazy or he's lying and he's not crazy. Because it's a tautology and Q is always true if we have the structure of this expression. it will also, on a more abstract level, if we use similar methodology of logic, we can explain why certain relations between propositions exist, why they get us the results that we intuitively know, right? Because you don't have to calculate this truth values in order to know that if I say either Joe is crazy or he's lying and he's not crazy, what I'm actually trying to say is that Joe is lying. We can explain why we have this intuition, why we interpret it the way we interpret it. Anyway, so what do we now know? So we know that if we look at the truth, this does not explain the whole meaning of a word, of a sentence, of whatever. But if we look at the truth, and it will help us understand the relation between language and language external world. Furthermore, we now know that sentences express propositions. And we know that propositions can stand in logical relations to each other. And this is, for example, helpful if we want to infer from one proposition to another, which we do, right? And we've talked about two basic types of such inference, entailment and presupposition. And we've furthermore also talked about the fact that the different propositions have can stand in relation to each other in certain constellations that can be expressed by a number of basic logical operators, which are the following, right? Negation, conjunction, disjunction, biconditional operator, and material implication. I can imagine that it all looks very complicated and that it doesn't really look like linguistics anymore, at least not like linguistics as we've talked about it so far. But formal semantics and using logical methodology is something that many people do, and to a certain degree it can be helpful, and it is definitely helpful to know that this is being done in linguistics. So this is all for today. Thank you all for watching, and see you next time. Bye.